If we pause to look about us, we become aware not just of the great natural beauty that surrounds us, but also of the rich and varied fabric of man-made objects that enhance and enlarge our lives. Buildings in all their forms and for all their purposes, when sympathetically designed, can enhance the world we live in. Our great cities are a testament to man's prolific building program over the centuries. Civil engineers play a major role in this design and the creative construction of all our planet's structures. They must be experienced in hydraulics for our water systems and dams, aerodynamics for our buildings, mechanics for strength, the flow of traffic around our cities and countryside, the design of our motorways to enable us to travel with relative ease, our bridges, tunnels, and the behavior of our soil and rocks on which our great structures are to be built. In fact, some of the most impressive structures of our time are attributable to their craft and their skills. The Sydney Opera House, one of the most imaginative and innovative constructions in recent years, is seen as one of the world's great monuments to the skill of the civil engineer. And suspension bridges with their unique structures are perhaps everyone's idea of what they do best. The oil rigs that inhabit our oceans are accepted as being a good example of civil engineering design. In fact, all these impressive structures were designed and constructed by civil engineers who continue to play an essential part in producing structures for the modern world. Since earliest recorded history, mankind has sought to shape the natural environment, to furnish our everyday needs and to improve our material comfort. Whether to provide places of worship or assembly or grand final resting places, mankind has, through a process of trial and error, learned to shape stone, to produce structures of such effectiveness as to allow them to withstand the ravages of time. Inevitably, only the best survived. For many years, the principal building materials, timber and stone, remained largely unchanged. But with the dramatic changes brought on by the early industrialization of the 18th and 19th centuries, it was essential to develop new structural forms, which could take advantage of the qualities of the new, strong building materials becoming available. It was against this background that the science and profession of civil engineering was to emerge in the mid-19th century. For over 100 years, the infrastructure created by the Victorians has served us well. But age, increasingly heavy usage, and sometimes changes in requirements are making much of this infrastructure in urgent need of repair or replacement. Today, in virtually every area, major new projects are under construction. New power stations to replace the aging stock of coal-fired ones. New motorways to take the ever-increasing traffic. Tunnels under the Channel to improve our integration within Europe, and many others. In short, we are witnessing a new boom in the construction industry. And civil engineers are in great demand to support and continue the exciting changes occurring in our society. Today, there is an acute shortage of graduates from the civil engineering courses of our universities and polytechnics to satisfy industry's voracious demand. The civil engineering course run by University College London is recognised worldwide for its academic excellence and is, together with other well-known institutions, playing a valuable part in preparing students for Britain's growing industry. Recently, during a residential course, visiting students had an opportunity to see at first hand these rapid new developments taking place. During their busy two-day programme, they visited the extensive London Docklands development site, where a massive investment programme is underway to change the face of what was once a dilapidated area.
That's the site of this huge sort of 800-foot tower that's going up, the tallest in Europe, part of this £4 billion Canary Wharf development.
But I think probably if we go down to the new civil engineering office, they have some brochures that they've prepared for you about the Canary Wharf scheme. And I'm hoping there'll be a copy for all of you. So if you follow us, we'll go down now to the Heron Quay development, which includes the new civil engineers offices.
Then Canary Wharf came along and changed the whole formula. The land prices have rocketed. Now it's all high-rise development, high-density development, multi-storey car parks. There'll be no more of this sort of parking by the side. And, even talk of putting...
You'll see 12,500 people for a boxing event stroke pop concert. And at the moment it's the largest single-span building in the country. It's the clear span of it is actually 88 metres. As you can see, it's 21 metres high, and there's a workforce here at the moment of about 80 to 90 men.
The Channel Tunnel at Dover was of great interest, and they saw the often unseen and unsung support operations, like the casting of the concrete arches that will provide the linings for the tunnels. At the Thames Barrage, students had an opportunity to see for themselves this remarkable engineering achievement and to ask questions of an experienced engineer who explained some of the complicated design requirements presented to them.
Each of these ends weighs some 1,200 tons, and the leaf of the gate, which is in the bed of the river, 1,500 tons. We're going to go down to the jetty here, and then we should be going ashore. The roofs, by the way, are stainless steel.
Turbocharged diesel engines which drive brush generators generating at 11,000 volts, any one of which can run their whole structure. And also there's a connection to the grid on the south side, the national grid on the south side, national grid on the north side. The sheets are joined by flanging the sheets up at the edges and folding them over, like the joint you get in a tin can. And they're secured to the softwood by short strips of stainless steel, which are screwed with stainless steel screws to the softwood. And they found out, to their astonishment, that the whole of the gang were right-handed plumbers who were able to turn the joints on this side to see all right. When they came on the other side, working left-handed, they were very much slower, and this was putting the thing all out of gear. So Tyson's told me that they, at considerable expense, of course, recruited a special gang of left-handed plumbers to fix the sheets on the north side of each pier. That's what they told me.
A trip to the Institution of Civil Engineers in London's Westminster allowed students to learn of how, over the first 3 or 4 years of their work, they would undergo further on-the-job training. At the end of this period, they would take their final exams to become fully qualified and professionally recognised chartered civil engineers.
The Stevensons have very strong connections. Well, Robert Stevenson has very strong connections with the institution. Down that end you have Robert Stevenson, who is a renowned civil engineer and president of the institution, and down this end you have his father, George. This is probably the most famous engineering library in the world. It's got approaching 100,000 books in it. The library was set up largely by the bequests of Telford's books and collections, and also the books that he brought with him when he became president. When Telford was invited to become president in 1820, he'd never actually heard of the institution until that moment. It was very, very quiet.
They met engineers working in a variety of consultants' offices to see something of the ways in which civil engineers go about the important functions of design in a modern consulting practice, and to learn at first hand about the breadth of work.
Immediately, so one person spent about 10 weeks making a model of all the surrounding streets, and having built a model, which is a geometric description, you then get a capability to apply many viewing techniques.
This two-day course emphasized what graduates would be doing once they enter the professional practice. But the students also saw a little of University College, London, where in 1826 the first Professor of Civil Engineering was appointed. It was at this college that so much of our modern educational practice was pioneered. During the three-year degree course, you will learn more of the basic sciences involved in civil engineering, and will have ample opportunity to broaden the basic science through laboratory exercises and fieldwork.
Like the other way. Right on the other side, yeah?
Bottom, yeah.
See? I think that's where it's actually half of it is reflected in the other.
So watch carefully, you'll have to fast now. Here we go. We ended up with obviously quite a sudden failure there. Very different to that first beam.
Through a carefully structured series of interactions with industry, students will have ample chance to discuss their academic studies with professional engineers, and to learn more about the range and nature of the various tasks to be undertaken. As we have seen, the role of the civil engineer is broad, varied, and challenging. The task of regenerating Britain continues at an ever-increasing pace. If all this much-needed regeneration of the social fabric is to continue, and to reach the standard set in previous epochs, we need many more of today's brightest youth to enter this respected profession. For it will be they who will shape the Britain of the future.